Everyone makes mistakes, even seasoned professional developers. Welcome to Python Basics Finding and Fixing Code Bugs. It's okay to make mistakes. It is actually very common and normal. Idle is pretty good at catching mistakes like syntax errors or runtime errors. But there's a third type of error that you may have already experienced. Logic errors occur when an otherwise valid program doesn't do what it was intended to do. In this course, you'll focus on logic errors. Logic errors cause unexpected behaviors called bugs. Removing bugs is called debugging, and the debugger is a tool that helps you find bugs and understand why they're happening. Knowing how to find and fix bugs in your code is a skill that you will use for your entire coding career. In this video course, you will learn how to use idle's debug control window, and you will practice debugging on a buggy function. So let's get started. The main interface to idle's debugger is the debug control window, which we'll refer to as the debug window for short. You can open the debug window by selecting Debug Debugger from the menu when you are in an interactive window. You can then look for the string debug on next to the prompt in the interactive window that will show you that the debugger is running. Note that the debug menu is only visible when you're actually in the interactive window, but not when you're in the editor window. Now, what does that mean? Let's head over to idle and take a look. Here I am in an idle session and I have an editor window open on the left and I have an interactive window open on the right. I will show you that when the editor window is selected, then I cannot see the debug window up in the menu. But when I've highlighted the interactive window, then you can see that there's the debug option. Now go ahead and select debug and debugger. You can see the string debug on popping up, and also the debug control window appears. Now I've rearranged the windows, so I have my editor in the top left, the interactive window in the bottom left, and then the debug control window here, filling up the whole right side of the screen. Next, you'll explore the interface of the debug control window by writing and running a short program that has no bug for a start. For I in range 1, 4, j equals I times 2. And then you can print out an f string that just gives you information about these two variables. I is, and then the value of I, and j is, and then the value of j. Now you need to save this first before you can run it. So I will do that using Command S or Control S if you're on Windows. And once your file is saved and you can confirm that the debugger is on by looking at the debug on message in the prompt of your interactive window, then you can run the script, for example, by pressing F5. And once you've started to run your program, you might notice that it doesn't get very far. It stops and the debug window highlights, and you can see a message appear here in the stack window. Now let's explore the interface of this debug control window. I've just mentioned that you can see the stack window here that highlights the line of code. You can switch it on and off with the checkbox at the top. You see these 4 checkboxes, and one of them is called stack. With this one, you can switch on and off the stack window. And now let's take a look what you can see in here. What does this line that is highlighted actually mean? If you read it out, you can see it says under main.module line 1 for I in range 1, 4. So this might sound familiar. If you look over to your script, you can see that in line 1, you're actually saying for I in range 1, 4. So this is where your debugger stopped. And you don't even need to highlight this yourself, but you can check one of the other checkboxes at the top of the debug control window, and that is the source checkbox. If you check it, then idle will automatically highlight the current line that the debugger is looking at. And what this means is that line 1 is about to be executed. It hasn't run yet. So the debugger stops just short of executing line 1 and tells you about it, that this is what it's going to do next. So inside of the stack window, you can always see what is going to be the next line that will run. And if you have the source checkbox checked, you can also see it in your script in the source code. Next, take a look at what's underneath the stack window. And to avoid confusion, I want you to first check the globals checkbox as well. You may see that whatever was before at the top now jumped into the globals section of the debug window. And in here, you can see there's a bunch of variables that are somewhat strange looking. They start with these double underscores. You have dunder annotations, dunder built-ins, dunder doc, etc. And these are variables that Python defined in the global namespace of your script. You don't need to worry about them. They are just variables that Python always defines when running a new script. And inside of this globals variable inspector, you can see how your variables will change over the course of your program. The locals panel just above the globals panel does the same, but for local variables. If you will open up a local scope, for example, in a function, and define variables in there, then these variables will show up in the locals panel. And finally, to complete our walkthrough of the debug control window interface, at the top, you have 5 buttons: go, step, over, out, and quit. These buttons allow you to interact with the debugger and step through your code. They do slightly different things, and you will explore exactly what the buttons do in the upcoming lessons. This completes the overview of the debug control window. You checked out all the options that exist on here, and in the next lesson, you will start using some of the buttons, specifically step, out, and over, and you will use them to inspect your code in more detail. In the previous lesson, you got a high-level overview of the UI features of idle's debug control window. In this lesson, you'll look at the step, out, and over buttons and see what they do when you step through your code. Now, after you've started the debugger on this short script, you can go ahead and press the step button. You see that some things changed. First of all, inside of your source code, you can see that now line 2 is highlighted. Also, in the stack panel of the debug control window, you can see that the highlighted line now reads line 2, j equals I times 2, which corresponds to the highlighted line in your source code. Most importantly, however, you can see that in the globals panel at the bottom of your debug control window, you now have a new variable that popped up, the variable I, and it points to the value 1. This is here because your for loop in line 1 created the variable I and assigned to it the value 1. You might already notice how beneficial this can be for debugging if you can see the changing value and the changing variables in your code just as you step through it. Now, just as before, the highlighted line that you can see in the stack panel and highlighted in your source code as well has not executed yet. The debugger again stopped just before executing this line. If you press step once again, then line 2 is going to execute and the debugger is going to stop again at line 3. So go ahead and press step and you can see the stack changed. It highlights a different line of code. And in the globals panel, you can see additionally to I, you also have the variable j that now points to the value 2. Now, if you continue to press step next, You might expect that print is just gonna display the message in your console and that's it. But instead, if you press step, you can see a new line being highlighted that says idlib.run.write, line 463 if self.closed. And if you look at the globals panel, it's suddenly populated with a lot of information and a lot of variables that you've never seen before. Also, you might notice that the locals panel now has a string that looks familiar. The string is called S, and it says I is 1 and J is 2. This is what you expect to be printed to the interactive window. But it hasn't shown up there yet. So what is happening? If you still have the source checkbox checked at the top of the debug control window, you will see that there's also an additional file that opened up. This file is called run.py, and currently you can see that line 463 is highlighted, just like the message in the stack trace told you. The reason why you see this is that if you use step to step through your code, it will also step inside of built-in Python functions. In this case, you've stepped into the execution of the print function that is part of your script on line 3. Now, there's a whole lot of code that this is going to go through if you continue pressing step. Go ahead and try a couple of times. You can see it just keeps jumping through Python internal code. And this is not very helpful for your debugging session because most likely the bug is somewhere in the code that you wrote and not inside of Python itself. So what you can do to get out of this situation is you want to press the out button. The out button finishes the execution of a current scope and takes you back out of it. In this case, this will take you out of the internals of the print function and back into your script. So go ahead and press the out button. You might have to press it more than once because of the internals that you dug into. But at some point, you will see that you're back to the more familiar setting where your globals is populated with the couple of built-in variables that you've seen before, as well as I and J, and the locals panel is empty again. Go ahead and close this window run.py so that you're back to the start. And you can also see that for I in range 1.4 is highlighted again. And this is also the line that your debugger tells you is going to be executed next. Finally, you can see that in your interactive window, the string I is 1 and J is 2 has printed out finally. So as a quick mid-recap, the out button is helpful if you accidentally or purposefully stepped inside of a function, but you don't want to actually step through everything that's happening in there and you want to get back out. That's what you would use the out button for. Now you can continue to step through the code. Again, you will see the variables change in the globals panel and the highlights change in your script, as well as the message inside of the stack panel. And now if you step once more, you can see that the next line that will be executed is again the print function on line 3 of your script. Now this time you want to avoid stepping into this internal print functions code, and you can do that by pressing the over button. The over button will skip the internals of the print function and just go to the next line, which is what you might have expected by pressing the step button last time. So we'll go ahead and press over. And you can see that what you expect to happen, you can see the printout in the interactive window. You can see you're still inside of your script. The globals and the locals make sense. And also in your source code, the next line that's highlighted is the next iteration of your loop on line 1. Now continue pressing step 2 more times. Watch how the variables change in the globals window. And then once you reach the print function again, what do you think will happen when you press over one more time? So I go ahead and press over and you can see the message printed out and the debugger is ready to execute line 1 again. If you click step, however, the debugger quits. You can see that by the buttons being grayed out and the debug on string appearing in your interactive window. And this happens because your script has reached the end. The for loop ran 3 times and printed out the 3 messages, and your script has arrived at the end. And if that's the case, the debugger simply becomes unresponsive. And if you wanted to run it again, you'd have to start running the script from the beginning, pressing F5 again. Now, this completes a walkthrough of stepping through your code using step, out, and over. You use step to go from one line to the next line, and always stop execution before the next line so you can investigate the currently defined variables. And you also learned about using out to get back out of a function instead of needing to step through every line of, for example, the built-in print function. And finally, you also learned about over, that you can use to avoid stepping into a function, but instead just complete its execution and take you to the next line in your script. Now, there are 2 more buttons, and there's breakpoints, and you will learn about go, quit, and setting a breakpoint and what that means in the next lesson. In the previous lesson, you've used step, out, and over to step through your code more or less line by line. Often, however, you may know that the bug must be in a particular section of your code, but you probably don't know exactly where. And then rather than clicking step all day long, you can set a breakpoint that tells the debugger to continuously run all the code until it reaches the breakpoint. In this lesson, you'll set a breakpoint and you'll use the go button to inspect certain parts of your script more specifically. And by the way, breakpoints just tell the debugger when to pause code execution so that you can take a look at the current state of the program. They don't actually break anything. To set a breakpoint, click on the line of code that you want to set it on and do a right click or control click on Mac, then select the option Set Breakpoint. Idle highlights the line in yellow to indicate that your breakpoint has been set. To remove a breakpoint, do the same but select Clear Breakpoint. You'll see that the highlighting disappears. Now go ahead and set the breakpoint on line 3 of your short script. If your debugger is still running, then press the quit button to stop the debugger. This will not close the window, and the debug session will stay on. It will just quit the debugger for now. You know that it's currently not running if the buttons are grayed out. Now go ahead and run your file again, pressing F5. The interactive window will tell you that this is a restart and the debugger is still on. At the same time, you'll also see that the buttons in the debug control window are interactive again. And just as before, you can see that in the stack panel, the debugger tells you main module line 1 for I in range 1.4. So again, the debugger stopped just before executing line 1 of your script. Now, instead of stepping through your code using step, you will use the go button that, in combination with a breakpoint, will run the code until it hits a breakpoint. So go ahead and press go, and then inspect the state of your debug control window. You can see the stack now tells you that it stopped just before line 3 instead of line 2 as before when you used the step button. Also, inside of your globals panel, you can see that both I and J are already defined. If you press go again, then Python will continue running the for loop until it hits the next breakpoint, which is just before the next print function. As a result, you can see I is 1 and J is 2 printed to your interactive window. And you can also see that the variables I and J have both changed and now point to the values 2 and 4 respectively. If you press go again, then Python runs the third iteration of your for loop and stops just before executing the final call to print. You can see that I and J now point to the values 3 and 6. Now, just as before, if you press go once more, then your program is going to run to the end and finish. And just to try out the quit button, instead of running this final iteration of the loop, you will press quit and see what changes there. you can see that the execution of the debugger stopped before running the third loop, and your debug control window is in the non-interactive state. And that completes the walkthrough over the functions of your debug control window in idle. In this lesson, you've learned about breakpoints, the go and the quit button. You can set breakpoints by right-clicking or control-clicking on a Mac and selecting Set Breakpoint. And then you can use the go button to run all the code until the next breakpoint. The combination of these two features allow you to pinpoint specific areas in your code where you want to investigate the current state of the variables. This is a great help when debugging. Finally, if you want to stop your debugging session, you can press Quit. In the next lesson, you'll look at an actually buggy little script, and you will use your newly learned skills with the idle debug control window to find and fix the bug.